So we're asked to find the value of z alpha divided by 2 that corresponds to this confidence level. This part right here, the alpha divided by 2, means that it's a two-tailed confidence interval. So that hasn't happened too much before in the course. What that means is, try to get something I can draw on. Like on our discussion boards, when we were changing a z-score to a percentage, we were finding a one-tailed probability. Like if you used a left-tailed probability, that would be the probability that an airplane costs less than your given airplane. Or it might be, that it scored a lower score. In this case, we're constructing a confidence interval, which is like a net that we cast in order to try to capture the true parameter. Like when we want to know how the country is going to vote for president, we might get a sample and say 51% are going to vote for candidate A. Now that could be wrong, right? So we give a range of confidence so that we can be reassured of like how, where the percentage really lies. We could say it's between 50 and 52% are going for candidate A. That's a confidence interval. And we can have different levels of expressions of confidence. But notice that I made it symmetric around that number 51%. A confidence interval has the same amount of numbers on the left side as on the right side of your mean or of your population proportion or whatever you're trying to estimate. So basically what all that boring stuff means is that when we construct a confidence interval, we're trying to make sure that we have the same area in this left tail as we have in the right tail so that we're fair. Okay? There's other situations in statistics later on where you might want to have a more one-sided confidence interval, but that's not in this course. We're asked to find a z value that has a confidence level of 89.48%. That means they want 89.48% of the normal distribution in the center. Okay? We got to do a little bit of arithmetic to find out how much goes in each tail. Right? So the entire normal distribution, the entire bell-shaped curve has 100% area. If you take out 89.48, sorry, I know the writing's small. That's what I want. That will be what's left over to go in the tails. We just need to split it evenly. So we got 100% area. Take out the 89.48. That means there's 10.52% that needs to be in the tails. But we got to split that evenly because this tail needs to equal this tail. So if we divide that by 2, that's 5.26 for each tail. So that's the real key number, 5.26%, or in other words, 0.052. We'll go to StatDisk with that number, and that'll help us get the z value that we need. Okay, z is something where we assume that the normal distribution is happening. So click Analysis in StatDisk, go to Probability Distributions, and then it's a normal distribution that we're talking about. We'd use this one if it was t and not z, okay? But we're doing normal distribution. Now we don't know the z value. We're coming at this problem by using the cumulative area. Okay, we're trying to get a z value. Ours is 5.26%. Make sure to enter that as its decimal form. If you hit evaluate, that's the negative z value that corresponds to it, negative 1.62. I thought they'd have. Yeah, so we're yeah, there it is. There's the positive z value. Look, we're going to use the positive z value because this right here, this cutoff is negative 1.62. And this cutoff up here is positive 1.62. Actually, really, let me think about that. It really shouldn't matter because a confidence interval is plus or minus. It's kind of interesting that MyMathLab, I think they're going to insist that you use the positive answer. Yeah. The negative one should be fine too because when we construct a confidence interval, it's plus or minus z star times a bunch of other stuff. Okay, depending on what whether it's a mean. If it's a mean, it's standard deviation divided by the square root of n. If this is negative, well, it's a plus or minus symbol. You just swap the order and it still does the same thing. So that's interesting. I wonder if I try this problem again. If I enter this negative value, it doesn't like it. But I think they might be wrong here. I think the positive is fine, so I might write something to MyMathLab here.